Welcome to another episode of the Supply Chaney podcast. I am your host, Nathan Chaney, and today we're going to talk about supply chain modeling with Chris White, who, if I knew anyone in the world that was maybe an expert at modeling, I think Chris might be that person for me. So, Chris, let's chat about supply chain management, about your career, and maybe a little bit of modeling in there too. So, can you tell us a little bit more about yourself?
I sure can. So first of all, thanks for having me on. Great to meet you. We've met in person before. We're both in the Dallas area, so love to have other contacts in Dallas. I'm from Dallas, born and raised here. Lived in a couple other places, went to school in some other places, but born and raised here. Same with my wife. We've known each other since kindergarten. So
Wow.
I've known her longer than anybody. We haven't been dating since kindergarten. Don't worry, that happened later. But anyway, same neighborhood, that kind of stuff. Grew up in the East Dallas
Wow.
area, and went to, if folks know any schools, went to Bryan Adams High School in Dallas, and then from there went to MIT for undergrad, aerospace engineering. Always thought I'd work on the space station and work at NASA. Didn't happen, but that's all right. Let's see. From there, came back. I've worked at a company that's now L3 Harris, but it started as E-Systems and then Raytheon, so it's gone through, been acquired, a lot of different stuff. But anyway, nearby in Greenville, I'm in Rockwall now. Anyway, worked there for a while, went back to grad school, really started while I was working there, got into cycle time reduction and process improvements and things like that. At the time, it was called TQM, Total Quality Management. So went back to school, went to grad school at University of Michigan. My graduate advisor was Jeffrey Liker. So if anyone is from the lean field, they would recognize Jeffrey Liker as being one of the world experts in the Toyota production system. And this is 30 some odd years ago, so he was just getting started with that. I can remember that. And so anyway, was one of his grad students, and so did industrial engineering was the degree, but we learned a lot. At the time was called Japanese Management and Production Techniques. Now we call it Lean and Six Sigma, but a lot of that stuff. Loved it. And then so came back to the same company I had worked at before, worked there for a while, and while I was there, got married, and then we moved to Washington, D.C. for a bit. I tried to chase a job there. We were there for a few years, and for the year 2000 came back. From there, I then actually went back and soon after quit working in D.C., had taken a job with some folks that were at that previous company that I mentioned that then started their own company, so was with a small startup there. And then been in Rockwall ever since, working at worked at Bank of America. I was a VP of Technology and Operational Risk there. Had my own company for a while, did some stuff, then did some independent consulting. Now kind of back and with a startup.
All right. All right. Let's step back a little bit and talk about the inspiration that you had to want to go work at NASA, and like what was the driving force behind wanting to do that in your earlier days?
I knew that I wanted to do something with space. Ever since I was a kid, I'm drawing pictures of astronauts and space stations. I had my Legos, and I'm always building spaceships and things like that, and have the mothership with little ships, and I was always doing everything space related. So knew I wanted to do something. Was also good at math and technical stuff, so I was like, yeah, I guess I'll be an engineer. That seems to be the path. So aerospace engineer just sound like the natural thing. So
Right.
that's what got me. Then from there, I just asked my dad, hey, what's the best engineering school? I'm going to give it a shot. And he's like, well, that's MIT. I was like, all right, give it a shot. And sure enough, got in and had a great 4 years there, and was amazing. And we may get into this later, but one of the things I do right now, the modeling and simulation I do, was invented at
Right.
MIT, but when I was there as an undergrad, I did not know about that. And until literally the year I graduated, later that year, I found out, and it's like, I was right there where, kind of like the great place for it. But anyway,
Right.
so yeah, I always wanted to do that. Now I don't do anything with space, but I still have a big interest. I just like to watch everything. And I got some, if we got time for little stories, I got some little stories along those lines, but we can come back to that if we need to.
I've got to say, I've got to kind of admit that I also wanted to be an engineer. I wanted to be a mechanical engineer initially going into
All
college,
right.
and I didn't think I could cut it from a math perspective. So I went the cheap route and went to business school instead. I've always had
Well,
this
it
kind
looks
of
like it's paying off. Look,
it worked out. It worked out. And so I get to play engineer at home, doing DIY projects and messing around in the garage. And so, but what have found in working in supply chain management and whatnot is that I feel like some of the most impressive business folks, are engineers. And so many of the people, like when I was working at Texas Instruments, 80% of the whole company, I think they said, is engineers. Even the people that
yeah.
are in business seats or business development or operations
Yep.
or supply chain, they're all chemical engineers or electrical engineers that have all gotten an MBA.
Yep.
And now they've got this really amazing engineering mindset, but with a business acumen. And I've always felt those are the smart guys in the room. Like if I could go redo things, that's what I would do. So I'm, for me, good job to you. That's awesome. And that you're able to apply your engineering sort of mindset here in the business world. But can you talk a little about maybe how you apply, the engineering principles that you learned back in the day to supply chain today?
I can, and I want to go back and say, I mean, clearly you are an engineer. Look, all this technical stuff that you're doing, the technology that you're dealing with, you helped me get all set up. I mean, so clearly you've got that in you. But if you think about it, so engineering is about learning how to make a system make something better. Generally, that's something you could call a system. Whether it's a single thing, but it's made up of many components, and so often it's still a system aspect to it, or some
Mm-hmm.
big system like a space station or something or an airplane, that you really think of as a system. But those kinds of things, businesses are also systems. You got a lot of interacting parts, departments, people, all that working together, try to accomplish the same goal. So you got policies that direct them and things like that, processes and IT systems, all that. And so they are also systems. So it is not a far stretch, to me at least, to apply engineering principles to businesses. And let's take supply chains as well. And if you think of a supply chain, you got a lot of independent actors. I like to use a sports analogy myself. You got a sports team. You got a lot of individual players that all play together, and they've got teamwork. They pass the ball. They run plays or things like that, and that's not much different than a business. Not much different than a supply chain. In a supply chain, again, you have a lot of independent actors that are somehow working together. We say working together, but they're really working rather independently. That's part of the problem, is they're working independently. They're acting, reacting, responding to whatever information they're getting, orders from a customer, shipments that they got from their supplier, and they're making reactions. So what we do actually with SCM blocks and some of the stuff that I studied at MIT are engineering control theory of systems, and that's what we sort of apply. So if you think of the thermostat in your room, you set the temperature and it's turning off and on to meet that temperature. Well, that's a feedback loop. That's what we call a negative or a balancing feedback loop. It's seeking balance. It's seeking a target, and that's what it's trying to do. That's not different from a company that has a level of inventory and they're trying to keep that level of inventory. That's a target. They're making orders and adjustments based on how close are they to that target. Are they over the target and they need to stop ordering? Are they under the target? Do they need to keep ordering? Just like a thermostat's turning on and off the air conditioner. Well, here in Texas, it's always the air conditioner because it's always hot. And so those act very similarly, and so that's what we're trying to capture. Are some of these things that might normally be seen in the engineering world, but they can really be applied to managerial and social systems as well. So, not a big stretch.
Everything.
To me, that was an easy lead.
Yeah. Sorry, I didn't realize that was a softball question. So I believe that you're right, that everything is a system. And if you can be kind of a master of how to think about systems and build them with the feedback loops and all that sort of stuff. And, maybe now we're getting into machine learning and all that sort of stuff, and being able to have a machine that learns that feedback loop and improve itself. That's genius. And actually I think you're coming out soon with like take it to the whiteboard sort of sessions. And I felt really honored that you shared some
Correct.
of your practice ones with me the other day. And when you were showing that a system is basically a set of parts and the interactions and the relations that they have, I literally was starting to think about that way in some conversations I was having just a day or two later. And so the power of knowledge and understanding how things work, right, it's amazing. There's a question that I ask most every person that comes on the podcast, which is, if you were to go back to yourself back at MIT and say, hey, one day you're going to be supply chain, an adjunct professor at a college teaching supply chain modeling and some of these courses, what would you tell yourself to get you better prepared for what you do today?
It's funny. I've often thought about that, and I've really wondered. And I mean, if you take all the personal stuff out, like I don't want to change my life because, married, love my wife and daughters, and you wouldn't change any of that. So let's take all that off the table. But you're just talking professionally here.
From a pure professional, yeah.
All right. I made the comment that the year after I graduated, later that year, as I found out system dynamics, I got into that. It all started with this book called The Fifth Discipline by Peter Senge, who was one of the first students of system dynamics, which is the kind of modeling and simulation we do. But anyway, system dynamics was invented at MIT, and I didn't find that out that was the big kind of place for it. That was the big concentration, lots of folks, lots of even programs and degrees in that area and classes. I didn't find out till after I graduated. So I've always wondered, gosh, if I knew that and I was back there and I got into it at that point in time, what would that have done, and how would that have changed the trajectory of what I've done? And I got to say that I think I would have lost a little bit. What helps me now, I think, personally, just me, and people can agree or disagree, is I've had a wide range of experience now. I was manager of TQM, Total Quality Management. I've done a lot in Lean and Six Sigma, done a lot of things in different worlds, proposal development for companies, worked with cities and government agencies, a lot of process improvement stuff, a lot of focus on processes and everything, and quality, and how to make things better, and how the processes themselves can make things better, and how all those interact. If I didn't have that, I wouldn't have the appreciation for the simulation that we do right now and what system dynamics does. In fact, what got me into it was when I was a manager of TQM at Raytheon, this is years ago, we were doing process improvements, and it's all on paper, kind of here's today and here's the future of what we want. And that's on paper, and you're kind of showing the two of them, A and B, and that's great. Well, what we found was that some of the things that we thought were going to be these great, fantastic improvements barely moved the needle. I mean, they made improvements, but not on the order that we thought. And some really, really just minuscule, like, oh, this is an easy change, no brainer, just go do this. Those things ended up being really big and having this cascading effect and having a much bigger impact than we thought. So I got into the modeling and simulation as a way to understand how our quality improvement projects could do better and how we could predict more of what we were doing. And so got into that, got into all the processes and the flows, and got into system dynamics. And so, again, had I not done some of that, I think my focus would have been strictly within the world of system dynamics, which is great. But for me, the business perspective that's being added from all this other stuff I did comes into play, and to me is very helpful. And now when we apply it to supply chains, I can talk about how it's not just, here's just this model. I can say, well, these are the things that happen in the real world, and this is why this approach works better than other approaches. I've used these different tools. I've used these different approaches. I know tactical versus strategic, all this stuff that I've learned from being in the business world for 30 some odd years. And anyway, so at times I really do think about it, but I have to say maybe it's good that it worked out the way it did.
For sure, because you have this wealth and breadth of other experience that you can draw on, to make your case more compelling and kind of add more context to what you're talking about in any situation. Can you talk a little bit about your time at Bank of America and how that sort of applies here again to kind of SCM blocks?
Well, okay. So one of the big things with SCM blocks is that we are looking at risk. We are looking at risks within supply chains, and these risks are usually the bigger ones. So we're not playing in the world of short term, figure out what happens tomorrow, the next week. We're looking months or years. In fact, a lot of the work we did for the military was in decades. So we're looking long term, strategic to try to understand how this big supply chain, all the way down, many, many tiers down, acts, reacts. You've got adjustments and ripple effects going up and down. Think of toilet paper and the pandemic, or any of those. Toilet paper was one of them. That's the easiest one to pick on. But the the personal protection equipment, all of them.
Yeah.
Chips for manufacturing. Trucks sitting on on the lots that we're waiting for these chips to arrive. And so a lot of things like that. So this bullwhip effect, this over ordering and lots of inventory, then nothing, and things like that. So those, that begins to play in. And so again, I mentioned risk. So when I was at Bank of America, I was the VP of Technology and Operational Risk. Operational risk is exactly what the supply chain is trying to get at, except in a much bigger picture. So when I say operational risk at Bank of America, it's within the bank of what are we doing and what operations, what processes, what activities are risky for us. That may end up in a legal suit. That may be something that we're not following regulations, those kinds of things. And then that's exactly what we're doing with SCM blocks, is some of that. So it's again, not too far of a stretch of taking this idea of risk management, both for the short term and the long term. And at Bank of America was within the walls of one company, but now we're going to do that, but many, many, many times for many, many, many companies, and it's this much bigger problem and simulation, and that's what SCM blocks looks at.
Gotcha. And what does the scene look like out there in universities today when it comes to simulations and modeling and that sort of stuff? What does curriculum look like? What do people do to get hands-on? I mean, it's not something that I've done in any of my coursework, working on undergrad or masters. So can you kind of walk us through a little bit that? And I'm going to turn down the light over here because it's getting really bright while you answer that.
Okay. Sure. And I will definitely do that. And I don't know that you just pitched me another softball. So one of the things that we do, so you talk about what's in programs right now. There is a lot that's still old and has been around for decades, but what is beginning to be new is what they call network design and optimization. So it's looking at your supply chain from your suppliers to you, to your distribution centers, out to your customers, and looking at that and trying to figure out the best layout for that, how to optimize that, how to minimize costs, all that. That we have seen has actually caused some problems. So with all the pandemic, some of this very lean, and as much as I like to do Lean Six Sigma and everything, you can be too lean. The more lean you are and the more efficient, then the less resilient and the less reactive you can be and adaptive. And so there's this balance, and that's what we're trying to do with SCM blocks, is introduce this balance. But you talk about what's in the curriculum, and some of the things of late are more network design and optimization types of things. And AI, of course, is creeping in there, and how AI is used, but that's relatively new. And so the softball that you pitched me was that SCM blocks, we have another version of that that's free that we provide universities called the Beer Game on Steroids. And if you're in the supply chain world, you've probably played or heard of something called the Beer Game. And the idea with the beer game, and a lot of schools actually do this as part of their supply chain courses and curriculum and MBA courses. They do the beer game because it's such a great learning experience. Well, the beer game, by the way, comes from the field of system dynamics. So tie me back to MIT and system dynamics and all that. So the beer game comes from that world, from about from the 1960s is about when that was created and turned into this sort of role-playing game where you could be the beer factory, you could be a wholesaler, a distributor, a retailer, and everyone's playing these roles. And what you learn from the beer game is that the individuals don't influence the system as much. So if you paid attention, Nathan, when I was talking about parts and relations in my Take It to the Whiteboard, which there's the whiteboard right there. So anyone that hasn't seen that yet, eventually I'm going to start running a series called Take It to the Whiteboard, where anything that's kind of complex, and I love drawing on whiteboards, so we're just going to take it to the whiteboard. So y'all will see that eventually. But in complex systems like supply chains, the relations tend to dominate and the individual parts don't matter as much. So when you take the beer game, the individual players or the parts, they don't matter as much to performance as the system, the structure of the system itself. The relations in that system itself is what drives the behavior, creates the bullwhip effect that everyone is used to seeing. But the real lesson behind the beer game is not, here's the bullwhip effect. It's that the structure of the system drives the behavior. The relations in a complex system drive their performance. So that's what you hear me talk about sometimes. And so that is what the beer game is trying to do. What we do with beer game on steroids is we go beyond the beer game and say, but instead of just having 4 entities, you could have 10, 20, 50, go crazy and get very complicated and begin to learn the physics of supply chains. If the supply chain is longer and has more tiers, how is that good and how is that bad? If it's shorter, how is that good? How is that bad? If I got multiple suppliers, how is that good? How is that bad? Learning all those things so you know the trade-offs, because there is no one silver bullet, by the way. There's no one perfect solution. It's always going to be a trade-off of some sort. And so we're actually providing that. So now some of the universities, getting back to universities and what they're doing, are using the beer game on steroids as a learning enhancement in their courses, to have students do that, build some models, get bigger, and learn more about supply chains than just what the beer game sort of teaches. But it takes the lessons of the beer game and expands. So that's some of what's going on, I think, in universities there.
Gotcha. And if you could take a second, I believe that I've seen on your sort of profile that you've been an adjunct professor, and you've been a teacher at some universities. It's something that I would like to do someday, maybe. Can you talk about just what that experience is like for you?
Yeah. Yeah, so I am an adjunct professor at University of Texas at Dallas. It's not like I'm there every day. I don't teach that much. I'm actually there for project management. I have a lot of experience in the defense industry, and there's a certain kind of project management approach in defense called earned value. And so I teach earned value when they tend to have a lot of people from the defense industry coming in. So one time they had a lot of folks from Lockheed all sort of moving through this master's program. One time they had a lot of folks from Raytheon, and so I'll go do those courses then. But it's been a couple of years. But I love doing that. And when I was manager of TQM, and even when I was the VP at Bank of America, doing all this stuff, there's always a training component to it. And I love training and teaching stuff. And if I ever take one of these personality exams, it always labels me as a pioneer or an innovator. And then the second is a teacher or instructor. And so I like to create new things and then tell people or teach them about it. So I'm actually in a doctorate program right now, almost finished, should finish in May, so that I'll have a doctorate. So then I can go teach when I retire from all this other stuff. I can go teach at universities, and because right now as an adjunct, I have to teach through somebody, but that'll allow me to do things on my own. So yeah, I hope to eventually get to that. Like I said, in my quote retirement. So I enjoy that a lot.
Gotcha. So you've had a business in the past, you mentioned, and you've got your own, setup now. Can you talk a little bit about, just some of the lessons you've learned, I guess, as being a business owner and an entrepreneur?
I can. And the first thing is no one's going to care about your business as much as you do. So just whoever's working for you or working with you or whoever you're talking to as potential customers, all that kind of stuff. I have learned that for sure. I've also we worked in an area that was very specific called the Small Business Innovative Research Program, SBIR. So if you're a small business and you make something, you do anything with software, create stuff, you're doing AI things, you need to check out the SBIR program, sbir.gov, G-O-V, and that'll get you started. But it's a government program where government agencies, so Department of Defense, Department of Commerce, Department of Agriculture, Department of Transportation, Education. There's like 11 of them that do this, and the Department of Defense is the bulk of it, at like 50%. But it's R&D money, research and development money, that's non-dilutive. So you're getting money from the government to develop things that the government has no ownership in. So when you walk up after you finish your grant or your project with whatever government agency, again, we did a lot with Department of Defense, Air Force, Army, you walk away and you own everything you did. So that's in fact how SCM Blocks was developed, was through an Air Force SBIR program. And so we did a lot with SBIRs. That was the bulk of what we did. Also did some other independent work as well. And back a decade or so ago, it was 2008, 2009, 2010, recession hit. It was very tough to be a small business in the government contracting world. That was where, so I also learned, don't put all your eggs in one basket. There you go. So no one's going to care as much as you, and don't put all your eggs in one basket, because when that hit and the work from the government started to slow down, to the government, one more month doesn't mean anything. That's no big deal. They're like, oh, well, we'll talk next month. But that's another, I'm putting, tens of thousands of dollars on my credit card to pay for payroll to keep everybody around in the hopes that this contract's coming soon and all that. Finally just stopped with all that, and we kind of broke up the company. Everybody went their own way. And unfortunately, like 3 months later, it was 2, 3, 4 months later, something like that, but fairly soon, customer came back and said, hey, we're ready to go. I got rid of everybody. Everybody's gone. I'm not bringing them all back. Some of them moved away. It's done. So I then started doing management consulting for a while. So the company has actually been around, and now we're just kind of coming back with the emphasis on supply chains. We have now created the startup SCM Blocks to begin to look at supply chains. Now that everybody watches the news, you got little kids that could say, hey, there's a disruption in the supply chain. It's now just so common that now's the time. So we were doing some of this work back then, 15 years ago, but it wasn't as advanced as what we're doing now, and it also wasn't the environment wasn't ready for it. No real supply chain problems, so not that big of a deal. But then here comes the pandemic and Red Sea and Suez Canal and you name it, any of those problems. And now everyone is paying attention, and the risks in that supply chain are very important, and understanding how they play out over the long term, years, is very important, because those are strategic decisions that can influence millions, even billions of dollars for companies. And you want to make sure you're kind of strategically pointed in the right direction. And that's sort of where we're heading with SCM Blocks.
Gotcha. Okay. Well, that sounds like a much smarter approach to building a business than I could have ever even thought of pursuing. So in all of the things that we do as supply chain professionals, we may start out our career as an analyst or a coordinator or something like that, but soon enough, you're going to find yourself as a supervisor and a manager, and then a director and then a VP. And there's a lot of leadership that is required. And I'm just kind of curious from your perspective, if you've got any thoughts on that topic.
I do have. I have a lot of thoughts. And guess what? They have to do with systems. The company is a system, and who makes the rules of the system are those that are higher up. So if you're an analyst, like you said, let's go from analyst up to VP, something like that. When you're at the analyst level, you have very little influence on the structure of the company, and by structure, I mean the processes, the directives, the policies that are in place, the IT systems. You may play some role, but by and large, your influence is somewhat limited. But yet you are heavily influenced and impacted by those decisions. Well, then it flip flops, and as you go up the organization and you're getting up to that VP, it sort of flip flops where now you have incredible control over something, the systems and the processes and the policies that impact everyone else. And you are actually not that influenced by them at the level that you are. So it completely flip flops. So as a leader, one of the first things for me is you got to appreciate that. You got to appreciate that now you are in charge of the system that everyone else has to suffer through. And if you ever hear someone say, "Man, I went around the system to make this work," well, that's horrible. That's not what you want. You want the system to be the path of least resistance that, hey, if you just follow this, you're doing everything we want you to do. All you got to do is follow this. Let the processes do the heavy work. Don't rely so much on the people. People are great, and you want better people, obviously, because someone could sabotage. But by and large, it's the processes and all these systems that you're putting in place that drive the behavior, drive the performance of the company. So as a leader, you have to know that you control it. There's a quote from W. Edwards Deming, who from the quality field, this is me way back doing quality stuff in the 90s, that said 94% of problems in companies are made by the system, so therefore they are management problems, and so only 6% is really individual problems with people. And that's stuck with me for a long time, and is part of also why I had that system influence the whole way along, even looking at it within the quality world. And now, of course, as we're doing simulations, it's all about systems. So,
Gotcha. Okay. I'm kind of curious because it can take 10 to 20 years for that analyst or that ground level employee to get up to be in a position to influence the structure. And by the time that they get there, maybe they're good ideas or they've lost touch, because when you get to the VP level, you've lost a little bit of touch with your younger self when you were down at the working level of the organization. Is that something? I mean, is there a way to combat that, or I don't know. It's just I'm kind of wrestling with this idea in my head that you just planted there.
well, in my opinion, there are ways to deal with that. First of all, and a lot of people would say this is not just me, but a leader, being a leader, doesn't necessarily depend on where you are in the organization. What I just talked about there was leaders having influence over the system and controlling the system that everyone else kind of has to suffer through. But leaders can be anywhere at any level at any time. And so to me, if you are doing that along the way and appreciating that, and as you work on teams, I'm not saying force yourself into a leadership, like I'm going to own every team I'm on, and by golly, I'm going to be the loudest person in the room, and therefore the leader or whatever. But to appreciate the fact that sometimes you're leading, sometimes you're following, because I tell you, good leaders make great followers also. And in an organization, you find yourself being any one of those at any time. So as you're moving up, appreciate that and understand your role as you're working in processes or on teams. Understand your role and understand how you can influence that even within that smaller world. One great things about systems is they're hierarchical. So you got the human body is a system, but it's made up of organs that are also systems that make a cells that are also little systems. And so it's hierarchical. So a team itself is a little system that has structure, has feedback loops. Gosh, we're going to meet every Monday morning. These are the things we expect. We're going to do work. We need to check in a feedback loop. Did we get the work done? Did we make the progress that we thought? So even in a team, you've got a little bit of a system. And so you can be a leader in that little system and still appreciate the idea of creating the structures that make that system effective.
Yeah, and you do that, and then you get responsibility for making another system and team that's a little bit bigger, making it better.
Hopefully so.
Yeah. Let's see. Maybe there's time for one more here.
Okay.
Is there Is there a topic that we haven't talked on today that you are passionate about, that you want to leave with people, make sure that they kind of take away with them as a result of listening to our chat here?
I do, and whether you're an advocate or a user of SCM blocks doesn't matter. But I want to talk about business tools and approaches and how they are used in the business world, and I want to tie it to a time frame of short term tactical or operational, and then longer term strategic. And there are certain approaches and even as technical as modeling methods that are good for short term views and short term analysis, and there are some that are better for long term views and long term analysis. So we need to have an appreciation for that one tool does not handle everything. So if you want to look at strategic problems, you may be using one kind of tool. If you want to find out what happens tomorrow, you may be using another kind of tool. And so we've got to be willing to go from tool to tool and not so much be, this is the one tool we bought into and it's got to solve and we got to use it on every single thing. I'm going to take this one hammer and everything's now a nail and I'm going to go around and do that. Not the case. So in the world of in the world of supply chain management, a lot of that is happening, or I'm sorry, there's getting to be a recognition that a lot of that we need to pick our heads up and not be so short-term focused, that a lot of that is what caused some of the brittleness, the inability to adapt that we saw in the pandemic, or even still are seeing now, unfortunately. Even after the pandemic, companies are tending to go back to what they were doing before because it seemed to work before, so we're going to kind of fall back on that, even though we've learned all these lessons. And so the message and what I'm passionate about, again, regardless of tool, is as companies and leaders in companies that control the systems need to kind of pick up their heads and look long term and understand there's different approaches to use, and that we need to make some strategic decisions, balance those with our short term, and not just live in this short term cost focused world, but be in this longer term value added kind of approach that, we will make sure things that we're doing have a better long term impact. Because unfortunately, 9 times out of 10, I've been studying systems for a long time, the thing that is best in the short term is actually worst in the long term. The thing that is best in the long term actually requires some discipline and pain in the short term. Think exercise, think dieting, think school, anything. To get that long term, you got to put in the work, and it's not always immediate payback. When we seek immediate payback, you're creating a solution that is very myopic short term and will not satisfy the long term. And so I'm hoping it continues, folks lifting their head a little bit and kind of saying, okay, we need to do more balancing here, and and do some of this strategic analysis as well.
I really appreciate you sharing that. I think that was maybe my biggest takeaway from this conversation is that, focusing on the short term usually isn't good for the long term. And if you're focused on long term, you're going to have a little pain in the short term, maybe. I think that's really good. I appreciate you sharing that.
You bet.
I, in general, appreciate you coming on and sharing some of your story, your history, your experience and expertise on the podcast, Chris. And I look forward to seeing you again in person soon, probably at some conference or an event here in DFW.
Exactly. Well, thank you for the opportunity. This is wonderful. I've enjoyed your podcast. I enjoy what you're doing, getting out there to all the conferences, sharing what's going on, especially in the DFW, Dallas-Fort Worth. If you're not in Dallas, DFW stands for Dallas-Fort Worth. But in this DFW area, I really appreciate all the work that you're doing and kind of advertising things, talking to me, talking to others, getting all of that out there. So you've been doing a fantastic job, and I'm just glad to be a part of it.
I appreciate the feedback. Loop. All right. Thank you, Chris. All right. Have a good day.